with Vermicompost and Vermiwash. And the speaker is called Vincent Sindikubgabo. He's the founder and the managing director of the VERMIFAM Ltd. And more about Sindikubgabo Vincent, he did a bachelor in botany and conservation at the University of Rwanda College of Science and Technology in the biology department. After that, he went to different universities in Europe to study his master's. And now he started his business under the name VERMIFAM Ltd, where he is leading smart soil, a biochar-enhanced composting model, integrating Internet of Things-based MRV for global carbon markets. Cindy Kubgabo is also a global winner of the GRP Resilient Agriculture Innovation for Nature Challenge 2023-2025. And overall, Vincent is the innovative person I know. I am very happy to listen to his talk. You are welcome, Vincent.
Thank you very much, Vena, for such a great introduction based on talking about my background, what I did, and what I'm doing currently. So now I'm going to share with you what we call vermicompost and vermiwash, its impact, and why is it really necessary, why is it needed here in Rwanda, because we had even the chemical fertilizers here before and even the traditional vermicomposting system. So we're going to see all of this and why these vermicomposting and vermiwash are really important. And the word Smart Soil Plus, you will know why we did call it Smart Soil Plus. And some people who doesn't know about vermicomposting technology, it's a system where we transform organic waste using earthworms, specifically Eastenia fetida, the leadworms that you are looking on your screen. And now we are working with different people. We have partners with in this project, and we are happy that CoEB that I was working with during my internship more than 4 years, that they gave us an opportunity to present our innovation. So if we go to the problems that arised, well, the problems that called us to start this venture, which is VERMIFAM. And the VERMIFAM, as I told you, it has a mission to transform organic waste into a biochar-enhanced vermicompost and vermiwash. Someone can unmute.
Ate Jovan can mute himself because he's making noise. Ate?
Yes, I can continue.
Yes.
Yes, I can continue. So from the problems that call us to start these ventures, you can see we have a problem of chemical fertilizers which degrade soil health and water quality. You know that when we use these chemical fertilizers, they end up into the water bodies by runoff. Sometimes also we know about this biomagnification, like when we use them, the toxic components which are within these fertilizers, they end up into our food system, the food that we eat. So when we say about traditional compost, actually the traditional compost, there is an inconsistent in nutrient composition. For example, when you come here to Rwanda, you found that people who are practicing this traditional composting, like let me say hip composting, sometimes they are not, they don't have such a great knowledge to do it correctly, and they don't even follow the strategies which are really at a high standard or a good standard to help them to have a balanced nutrient for that final product they produce or that they sell to the farmers. And again, the third point, the farmers, they face a rising input cost and climate risks. When I say the cost, let's say, for example, if the fertilizer is at 1,000 Rwandan francs, some people here in Rwanda don't have such capacity to buy that fertilizer. Uh, and at the end, because we trained farmers and they said, okay, now we are investing our money into chemical fertilizers, but at the end we don't harvest a proportional harvest compared to what we invest in that fertilizers. So for the climate risk, here in Rwanda or in everywhere, that we have problems of climate change. Let's say about droughts and even the soil, which is really acidic. Here, for example, in Bugesera, where we are working from, the soil is more acidic and it needs something like to update its status. For example, for chemical, when you go to the nutrients from the chemical, biological, so you understand that this soil needs some helps. So then we go to our solution about these questions that we were discussing about. Let's say this vermicomposting is actually rich in humus and balanced nutrients. When you say balanced nutrients, you have NPK, nitrogen, phosphorus, and potassium. Not only that, but also in this compost, we have hormonal hormone growth, growth hormones for plants, sometimes which works on fruits and flowering of these plants. So it's really a component itself, which is made from this waste that we say that is organic waste that we collect from our household and local markets. And then we transform them using the stainer feeder, as I said, and I will show you the system, how it is constructed. And this, the final product that we get is really important, and you will see how it helps for the plants. When we go to vermiwash, it is a natural liquid biofertilizers and it works as pesticides. So it has a component. When we say a pesticide, it kills some pest, and it has a antagonistic mechanism where that those pests, instead of growing, those there is a chemical mechanism that goes away into the system of this pest, and then don't grow or multiply with their own crops. So for the carbon artisanal selling, actually, as we incorporated this carbon, this biochar into the system, you can see that now there is a need of a carbon credit market. And now we are at the stage whereby we're discussing with the atmosphere how we can sell our carbon credit and certify them internationally. So we are using Internet of Things enabled monitoring system where we test temperature, we test moisture, we test NPK and heavy metals. And we know the concentration of this, and then after knowing the concentration, we can know which nutrients is missing and how can we increasing the concentration of a specific nutrient based on the monitoring system that we are using. And here we have a proven research that this compound that we are producing, vermicompost and vermiwash, they boost crops yield by at the rate of 30-40%. So let's go to the case studies that we did ourselves with our partners. So for the case study we did the partnership with Sorwate. Is a tea company which is full organic. It is located in northern part of our country. We did a research together in their plots, and we did still the research is going, but we did almost is now 8 months working with them. And the application of this smart soil increased tea leaf yield by 25%. If you go to soil improvement, improved soil structure and reduced synthetic fertilizer use. And when we go to climate impact, we found that farmers reported better resilience to drought conditions. And we didn't stop from there, but also we did partnership of Bio here in University of Rwanda, but it's South African institution, organization which works here in University of Rwanda, and we are having a 6 months uh, um, testing where we are testing pH, carbon nitrogen ratio, total nitrogen, and the organic carbon of this compound. So you understand that we didn't sit and just say, okay, we are producing this, but we had to make sure that everything we are producing is scientifically approved and field. When we go to the field, also we test the field, the efficiency of this product. And we are testing the safe from contaminant, for example, for E. coli and Salmonella and heavy metals. And we are trying to certify our product internationally. So then why do we call this final product that we produce as a Smart Soil Plus? You understand that we have a system and a technology that is called Verm technology. We use this system because it's really the research have been made on this Verm technology system, whereby these radiums they have a chemical components, even they are liquid. They are sulfur within their gut. So they help this organic waste to be decomposed easily and quick, and they have this um, uh, capacity to make these balanced nutrients within the system. You can see now we have three main components. We have what we call a 7-1 soil sensor. So this one to help us to know those nutrients, NPK, temperature, moisture, and other physical properties and heavy metals property. And we have this Estenia fetida, which is the main um, uh, driver, we can say. And we include 20% of the biochar. If you see here, we have the vermicomposting system takes 80%, and 20% contains the biochar. And that's if, for example, if you were wondering why this is called Smart Soil Plus. So it's a combination, it's integration model, which combines this soil management, but tested with the technology itself. So, though we are doing this, we did this project also. This kind of projects. Though we are doing it, but it's a source of income also. We project to have at least 2026 if we go to the credit carbon market. You can see here we have three components. We have a vermicompost cell, we have vermimor cell, and the carbon credit. And carbon credit. And but for the projection, you can see for the carbon credit, that's where we are relying, and that's where we see that the revenue will come from compared to other products that we have into at VERMIFAM Ltd. So for scaling this project or this initiative, you can see we need to have hubs in all districts of the country, starting from Jesera where we are working from, and have an initiative to reach at least 50,000 farmers by 2028. As I said, we have partnered with cooperatives and Sorguate private estates and other institutions, District of Bugesera, we are partners, and GRP, the Global Resilience Partnership, the South African in a support with Shockwave Foundation from US. And you can see that in the future, this will give us a good outcome. So for the smart soil, in a summary, you can see that it is a healthy soil, a healthy harvest, and a healthy future. It's a healthy future because even the community which are using these fertilizers that we produce, they will be um, safe from contamination of any chemicals that come from outside. And you can see they boost yield sustainably. They reduce input cost because our fertilizer, it's the cost is really less. Now the 1 kilogram is 400, 300, depends on the quantity you take. And for the liquid, it's only 1,000. And the liquid 1 liter can be diluted into 20 liters of water. So you can understand that this reduce the input cost and restore degraded soil. As we said at the beginning, you know that this system, it will help to do that. And for the scale across Africa for climate resilience, and we discussed about it. And if you have any question, please, you are welcome. Thank you.
Oh, thank you very much. Yeah, my colleagues here are welcome to ask a question or comment on anything. Uh, but my quick question is, did you also study the impact of this vermicompost and vermiwash on soil biodiversity in general?
Thank you very much, actually, for asking such a good question. But this vermicompost stuff that we are doing, uh, other people, they did the research. So there is scientific reports that published about it. So we didn't do it by ourselves for this fertilizer that we're producing, but other people who are doing the same project, they did such kind of research. Thank you.
Good evening, everyone. Thank you so much for the presentation, our presenter. My name is Elvis Mujuni Kamara. I'm a student of botany and zoology at Makerere University. So I'm listening in from Uganda. So I have a question, and
Yeah.
uh, my question is: did you face any challenges in your improvement as Smart Soil Plus, and what challenges were those?
Thank you very much. My colleague who is doing botany, as I did in bachelor. The challenges are there, of course. At the beginning, we faced the challenge of people who were not aware of this kind of products because they are familiar with chemical fertilizers, and to believe in you have to have a big impact, right? And have a big report, I mean different reports about your research as I did, and to approach you at the production site and run how you do it. Because and another challenge that we faced, um, for example, when we were looking for partnership with other institutions, it is not easy to convince someone, for example, to that you have a new product which is really a substituent, or it's something that will help the community at large, because this fertilizer that we are producing, it's not for ourselves, but it's for the community. So it's for the country, it's for the region. So to convince institution like big institution, for example, Sorwate, which agreed to work with us, and we thank them that still we are working with them, and we have other project that we are dealing with. So as the times I was saying, it's not easy to convince people or the institutions that you have a new product, for example, as a starter, because we started in 2021 and now it's almost 4 years, 5 years. The currently we have the capacity to produce 60,000, 60,000 ton per month and 5,000 liters of vermi liquid. So you understand that we start at small scale, but now we are pushing to a large scale. As I told you, the challenges also, for example, we had a due diligence with Atmosphere. It's a Germany NGO. For this, they were like to convince them to invest in you. You need to prove that what you are doing is really reported for everywhere. And for example, they ask you different reports, like, for example, if you have a contract with a supplier for organic waste, you have to show them the contracts which are really signed. And for example, if you are working with Sorwate, you have to have MU, memorandum of understanding. So to gather all documents to convince such a big NGOs from, for example, which are international, you need first to have a big team. I mean, the good team, not a big, but good. Like whom you are working, believing in yourself and believing in our team, because you can't do all alone. So the challenges are there, but you have to face them and break them. Thank you. Is there another question?
Yeah, let us look for further questions. As a reminder, you can also write in the chat room or unmute yourself to speak. Yeah, either ways. Yeah, David.
Hello, thank you so
Thank
much.
you. Thank you so much.
My name is David, and I'm a graduate from the University of Rwanda. I did agroforestry. I would like to ask our presenter how, to what extent, vermicompost is better than normal compost, and if from his own research he would encourage them to shift. He would encourage farmers to shift from the normal compost to vermicompost. Thank you so much.
Thank you very much for your question. I can say it's good to use this Smart Soil Plus. As I explained from the beginning, I showed how it's really good in aspect of environment first, and the mode of action. For example, for the mode of action, when you see to the chemical fertilizers, they kill the living microbes. In Kinyarwanda, we call them abakunzi b'ubutaka. Actually, these living microbes, so for the chemical fertilizers, the mode of action, they kill those living microbes which are in the root zone of the plant, and then they immediately act on those on that area. But for these chemicals, I mean, from this smart soil that we are making, it's really different. For it just create the living microbes around the root zone of the crops, which immediately those living microbes help the nutrients immediately to attach on the roots of the crops. So that's the way of action of these two different chemicals. I mean this output. And another point of view, if you see to the biodiversity, what I was saying about runoff, someone can unmute Kitenda. Yes, thank you. I was saying, can Kitenga unmute so that I can reply to the question? Yes, thank you. I was saying, if you, apart from the mode of action of those two different compounds, you can see when you use these chemical fertilizers, they end up into um, water bodies by runoff, and they kill the living organisms into the water bodies, of, for example, fresh water bodies, which are really important for us and for uh, our biodiversity. And not only that, but for the harvest itself, you, for example, imagine if you use these chemical fertilizers and then you produce much this year, but next year you don't produce much. You don't produce when you don't use that chemical fertilizers. But for this smart soil plus that we are using, it can stay in the soil more than 100 to 1,000 years because we inoculated the biochar within the system. So you understand that these fertilizers themselves, they are resilient and they can stay longer within the land use. And even for the mode of the action, you saw that it's really different from those chemical fertilizers. I don't know if I answered the question well. Thank you.
Thank you. My name is Kubwimana Venat. I'm graduated in agroforestry in the University of Rwanda. I have two questions. The first one is, we see different type of fertilizer applied on certain type of soil. I'm asking myself if it is this type of fertilizer applied to all type of soil. The second one is this type of fertilizer applied to all type of crop or is it some of crops? Thank you.
Thank you for the question, but will you mind to come up on the first question, please, because I didn't get it well.
Thank you. My first question, I ask if this type of fertilizer is applied to all type of soil, because in Rwanda we have acid soil, sand soil. Is this type of fertilizer applied to all type of soil? Thank you.
Thank you very much for your two questions. Almost similar but different by soil and crops. So these fertilizers that we are producing, the smart soil plus that I was explaining in the presentation, it is applied to all crops because they are coming from all residual, the organic waste that, for example, the agricultural waste that you, for example, rice waste, matuke, the banana peels, the vegetables, all of this, we feed them with the worms, and the worms transform them into those fertilizers. So it is applied to all crops, to any soil. So it's really good for lead, and that's why I said it's really important to even to mobilize your community, your farmers, that they can do even the research by themselves. They can buy, for example, those chemical fertilizers and buy this smart soil plus in their home garden, and then they try them in different season, then see. Yes, thank you.
Yes, Mr. Vincent, thanks for the presentation. My name is Chitenda Fabian. I'm also a community in Black Soldier Fly Royally in Uganda. I've just finished my studies from Makerere University. I have one simple question, or one question that I want to ask you, whether you have tried to use other compost manure from other invertebrate fauna, and you've tried to compare. Have you tried to compare the compost from other invertebrates such as the black soldier flies larvae? Have you tried to compare the two composts, the vermicompost and the compost from the BSF from the BSF fauna? Because even the manure from the BSF or from the BSF, I think also works better. Have you tried to compare, or have you tried to use them to compare? Thank you.
Thank you very much, Kitenda, for such a good question. Actually, we didn't do a comparison between BSF and vermicompost. I know here in Rwanda they're doing BSF, uh, black flies, soldier fertilizers, and even they are being applied it here in Rwanda, even using them in our land use. But to be honest, I didn't do comparison research between both of vermicompost and BSF products. But I'm curious, and I will do that. Yes, thank you.
Yeah, thank you very much. I see a question from the chat room. It's from Gilbert Ndatimana, which says, do you rear e-forms as well? Where do you get them to be introduced? Oh, where do you get them to be actually to introduce them in that engineering work? Did you get the question, Vincent?
Yes, I did. Thank you for the question. Actually, for these legumes, they are African legumes. They are locally found, but scientifically, we have eggs in cow dung. So we have a system where we make a favorable environment for them to develop, and then we inoculate them into the system. I don't know if he go or she got the answer.
I think he has got the answer. If not, he can ask a follow-up question. Yeah, got it. Thank you very much. Let me see if there is someone else who has final questions or comments. I see no more hand and no more question in the chat room.
Yes,
And
I can see Mr. Peter Lita
oh,
raised
yeah,
hand.
yeah. Thank you, David. Let me welcome Pitya Rita. Pitya, are you speaking? You are muted. Unmute if you want to speak. You have
Yeah,
something to say?
I've just joined. I've just joined the discussion, and I just need to know briefly about the vermicompost. Is it similar to the black soldier fly compost, or it is from different insect or from different material? I know briefly because I've just joined the discussion. Thank you.
Thank you very much. It's really different. For BSF, it's innovation itself. And for vermicompost, we use Estenia fetida, the radiomes. So it's really another different or technology. So they are the two different technologies.
Okay. Yeah. I see Jaime Rutechu Mugambi. Can
Yes,
you
Vienna.
say yes?
Okay, good. Thank you so much for the nice presentation. Although I've just joined a bit late, like 5 minutes before the presentation ended. So, but I have to, yeah, I can now understand the trend of the questions, also the answers. Then I want to ask the presenter about the sustainability of the project or the idea itself. I see this in this kind of project. Uh, I know there are threats of this soil biodiversity in terms of like the contamination of the soil, also with the climate change, everything is like affected. But I see that the resilience of this kind of project, that the landscape or the farmers should be able to make this or to produce this kind of fertilizers by themselves within their farms. How do you explain the sustainability of this project in terms of the biodiversity threats in general, the soil biodiversity threats in general? Thank you.
Thank you very much. For sustainability, when you say sustainability, you talked about farmers applying this vermicompost system by themselves. Yes, we train people, we train farmers, we train entrepreneurs at VermiFarm Hub how to do it, and some of them they go to train others because we train even readers of the farmers. For example, social agricultural promoters, and we have worked with district where we trained even the agronomist. Those agronomists they go to train other farmers. This is the sustainability. For example, if I transfer my knowledge to the team members of, for example, a cooperative, and that team member will go to train other cooperative team members, right? And then
Yeah.
those knowledge will be applied from different sectors via on-reader training. That's one example of the sustainability.
Yeah.
And of and another sustainability I can say, for example, if we go to the project itself, for example, where we are doing this project here in Rwanda at Bugesera site, you can see we started at small scale. Now we are at the large scale. So the sustainability is good. So it doesn't need this project doesn't need much capital to start. You can even start from your basin. The basin, you can start from doing the fertilizer at home in your basin. And this soil, as I said, this fertilizer is a soil amendment which can stay in the soil for more than 100 years. What you have to do is just to make it properly, because if you don't do it properly, you may end up having bad unbalanced or something which is not really a nutritious. I don't know if you get the point. For about biodiversity itself, I told you that this is something which is eco-friendly. It is eco-friendly, so it doesn't harm any biodiversity, but it helps this biodiversity as an example of these living microbes from the soil. They multiply, and when we have multiplication of these living microbes, we have the zone of a biome, which is where the biome will be healthier. And these redworms, they extend affected that they are the soil borrowers. So when they are moving within the soil, it themselves they create something like aerobic, so the water can go there, can penetrate easily. Yeah, not only the water, but also the compaction of the soil reduces.
Yes, I understand the phenomena, but I was asking like the phenomena in terms of the the landscape resilience. Like if some people here like, are talking about agroforestry, but if you see like how this can be like integrated into climate smart agroforestry, for instance, where like this agro ecosystem should be like have ability to sustain themselves, and also this soil biodiversity should be there and should be able to provide all these ecosystem services while on site on farms.
I don't get the question well. Can you come again and make it like a short question so that I can understand the question, please?
I'm not sure if I'm clear well for like the way I'm explaining this question.
Yeah.
Like this is, I was asking a question on the threat that's related to the threats of the soil biodiversity. This is actually a big challenge where like I see it, like this project, like in terms of it's a business kind of project, but I want to see like the sustainability of the soil biodiversity, and then the landscape agro ecosystem resilient, where this should be like applied project within a farm, like, and then the farm should be able to function and also maintain these functions without even the interventions of a human. For the sake of the landscape resilient. Yeah.
For the sake of the landscape resilient, you mean if you apply this kind of project within the landscape will harm anything? That's the question?
Yeah, he is saying, if I have got to where his question, he is saying agriculture is a threat to biodiversity, especially when it is done unsustainably.
Mm-hmm.
And he is asking if the use of vermicompost is sustainable ecologically, because agricultural land can also contribute much in carbon sequestration and biodiversity promotion. And his question is similar to mine, which says, is using vermicompost ecologically sustainable on agricultural lands?
Yes, if it's such question, I even I explained that in the PowerPoint. I said this is eco-friendly products. So they come from the waste, which are really, for example, agricultural waste. And when you, for example, if you put this agricultural waste within the environment themselves, they cause what we call a nutrient balance and nutrient imbalance. But because these are treated at the center, I mean at a vermifam, we treat them, and after treating them, we give the final product, which is really balanced nutrient soil amendment. So this one is really good to environment, to biodiversity, to anything, even to the health of the human. But when we come to the problem of agriculture, you know, in Africa and even in Rwanda, 70% of farmers, they say the 7% they are based on the agriculture. That's the report that we have. And in Africa, you can see we are basing on the agriculture. If you see the forest, we have, for example, in Rwanda, we don't have much forest. But the main trait is not agriculture, but even for living people, a house for living, that they can be a trade. But when we use a method, for example, a good system, for example, this mandament, that is really where this is where with a balanced nutrient. For example, this is something that with a good research on it and apply the method in agriculture, which is really sustainable with the environment. there will be no any problem. So you can apply in agroforestry this fertilizer. You can use them in anywhere of the use land, the farmland, or yeah, like that. I don't know if I tried to answer Vena to those questions.
Okay, I will just contact you, and then we discuss this maybe in a separate discussion, because I'm also very interested in this kind of work, let's say. But I'm trying to link it with the agroforest, climate smart agroforestry, landscape resilience, agricultural landscape resilience. So I will try to contact you in a separate email, I think.
Thank you very much.
Yeah, thank you very much.
And I'm willing to connect actually with you.
Yes, please, Jaime, drop your email in the chat room so he captures it. Yeah, I want you, Vincent, to respond to two questions in the chat room, then we close the discussion. From now, I will not receive any further question. You will start with the question by Ange Isabelle, which says, do you even use the effective microorganisms, EM? And
EM?
do you use effective microorganism in your
Active.
vermicompost? Yes.
Yes.
Okay.
Yes. For that, we actually the active microbes, microorganism, they are there. So the answer is yes.
Okay, thank you very much. Then the question of Emmanuel, which says, I would like to ask him a question about the yield resulted from that compost they produce. Is it applicable to the different weather conditions and different agricultural zones according to agriculture terms?
Yes, I did even answer that. As I said, this is the eco-friendly product. So it can be used at any season, at any land, within any crops.
Yeah, thank you very much. I had said that I will not receive further questions, but let me ask Fabien to ask the last one before I close. Fabien, you are.
Thank you so much. Thank you so much, Venat, for the second chance. I'd like to ask Mr. Vincent one burning question that when producing this type of manure, the vermicompost, should I also use the same substrates that I use in BSF to raise the earthworms so that I can come up with the vermicompost? When I solve the substrates such as waste food, also waste food, do they also work as the substrate for the earthworms? Then also the second question, the last question I would like to ask is that what are the conditions that are required for them to grow locally in a local way? If at all a person wants to start rearing them, what conditions, such as, do they require dark conditions? Do they require light conditions? What are the conditions that one should consider when establishing such a project? Thank you.
Kitenda, thank you very much for two questions that you raised. For the first question, we were curious if we can use the waste food. For the vermicompost, we don't use a cooked food because they can create acidic condition in the system. We use, for example, the agricultural waste. We can use the fruit waste. We can use any organic waste, but which is not cooked. Apart from using these Raymond, because Raymond they contain acids, and for the red worms they can't grow in acid medium. So for the conditions, when I touch on the conditions, what you have to maintain first is the temperature and moisture for them. So you can read about it because they have a maximum range for temperature and for moisture. And another condition, they don't work actually on the light. They always work in the dark condition. They are, of course, surface borrowers, but they work within the dark. When you put light there, they don't come on the surface. They only go deeper of the soil. So first, the three conditions: make sure to maintain temperature, moisture, and a bit dark. That's why in an open area they cover with blanket on the production system. Did I answer the questions well?
Yes, you've answered them, Mr. Vincent. Thank you so much.
Yes, thank you very much to Vensa Sindikubgabo for this great presentation. Actually, I can say courage. Keep up the good work, and I'd like to thank all participants here on this platform. Thank you for coming and listen to our colleague Vensa Sindikubgabo. It was very, very interesting to have you all. Thank you very much. And again, I'd like to tell you that welcome everyone who wants to speak on any subject related to research, innovation, or anything of spreading. And the seminar takes place on Wednesday at 3 p.m. and everyone is welcomed. Thank you very much. We learn from each other. We grow together.
Thank you, Mr. Fernand. Thank you, Mr. Vincent.
Bye bye.
Bye.
Any final word, Vensa?
The final word I can say thank you to this great platform I've been given
Yes, thank you, guys.
to share this experience that we have at Vermifam. And not only that, but also we thank CoEB because it raised me from the beginning when I was in my bachelor up to now. I can say I learned a lot from them and I'm still learning. And I hope to cooperate again in other future projects so that we can sustainably help our local farmers, our local community, and mitigate the climate change. Thank you.
Thank you very much. I appreciate. Bye, colleagues. See you next.
Bye.